To solve this data sufficiency question, we'll go ahead and consider each statement separately first, and then together if needed. Before we go ahead and dive into the statements, let's read the question. If a, b, and c are positive integers, is a minus b times b minus c times a minus c greater than 0? So let's go ahead and consider statement 1 first. Statement 1 gives us an equation. We're given a squared minus ac minus ab plus bc equals 0. Let's try to solve this by factoring. We can actually group our terms, the first two terms, and then we'll group the second two terms because each of them separately, the groups have different things in common. So this is called factoring by grouping. The first group have an a in common, so let's go ahead and factor out an a. And we're left with a minus c. The second group has a negative b in common. Factoring this out leaves us with a positive a, and it switches the sign for this last term, so minus c, and that all equals 0. Factoring even further, we can consider all of the terms together. They now have an a minus c in common. So if we factor that out, we have an a minus c times an a minus b is equal to 0. So a minus c times a minus b is equal to 0. Now let's go ahead and let's take a look at the inequality that we're given. So the inequality we're given is a minus b times b minus c times a minus c, and we're asked whether it's greater than or equal, or just greater than 0. Now, this would be the same as if we just rearrange the terms slightly. We have an a minus c times an a minus b times a b minus c. These two terms right here, this product, is what we found back from our statement equation. We know that that product equals 0. So we can replace that with 0 times b minus c, and that whole result is going to equal 0. Now, this was the inequality that we were looking for, the left side of an inequality, and we were asked to determine whether it's greater than 0. We found out that it's actually equal to 0, so it's definitely not greater than 0. This is a definitive answer, so we would answer our question, if those are positive integers, is this inequality true? Our answer to the question would be no. We can give a definitive answer. So that means that even though the answer to this question is no for this statement, that this statement is sufficient. We can actually eliminate some of the answer choices now. So we can eliminate answer choice B, C, and E. That leaves us with choices A or D. Now to narrow it down even further, we're going to have to consider statement 2. So let's go ahead, and our next thing that we'll do is we'll consider statement 2. And let's go ahead and delete these guys. Just creating some space. So statement 2, we're actually going to do a similar reasoning for this statement. So we'll factor by grouping. So let's go ahead and consider the first two terms and then the last two terms again like we did for the first one. First two terms have a b in common, so we'll factor that out and we're left with a minus b. The next two terms will factor out a negative c in common, and we're left with a positive a. It switches the sign, so minus b. And that whole thing equals 0. Continue factoring, we have a common factor of a minus b, and we're left with a b minus c equals 0. Tagging back to our inequality that we're looking for, whether it's greater than or equal to or greater than 0, we have a minus b times b minus c times a minus c, and we're trying to decide whether that is determine whether that is greater than 0. Now these two terms in the front, that product we found is equal to 0 based off of our statement. So we have 0 times a minus c, and that whole thing comes out to equal 0. And that is definitely not greater than 0. So again, we have kind of a similar situation as we did with statement 1. The answer to this question would be no. It is not greater than 0, that product. But since we have a definitive answer, this statement alone is sufficient. So we can actually eliminate answer choice A, and both statements alone are sufficient. So the correct answer would be choice D.